good to see all of my functional friends here. So last week we were talking, the clinical pro, we were talking about the liver and detox and bile flow and kind of that whole cycle. I think we talked about GGT a little bit. Such a big conversation to have around that. And I was just answering some questions in another group. But today I thought I'd give you a little bit of teaser. I've been finishing up my slide deck for this seminar I'm doing this weekend and working very closely with my graphic designer to try to bring some of these concepts, to life and illustrate some of these concepts, because I think a lot of us are kind of visual learners. I know I am. And, it's one thing to read about like a physiological process or biochemical process, but then to be able to kind of see it and contextualize it. So I've got a number of cool graphics, and they're not fully done. I'm still working out a few typos and whatnot. But this one I thought was kind of cool about histamine, leaky brain, and mental illness, because with just mental illness in general and histamine and MCAS, and I know a lot of you are very astute to MCAS and some of these histaminergic issues that can arise in a lot of these cases that we work with. And so I think it's really interesting. I mean, I had no idea. I had the basic understanding of histamine with being very, causing a lot of vasodilation and really opening up blood vessels to allow leukocytes and white blood cells to migrate to the source of inflammation and really facilitating kind of the inflammatory response. But the deeper I dig into some of these mechanisms, it's so interconnected and kind of fun and complex. So I got down to some of these details of how, as I illustrate here, the endothelial blood-brain barrier expresses these histamine 2 receptors, the H2R here. And so anytime we have degranulation of these mast cells and this release of histamine and heparin and serotonin, it will cause, an increased transcellular permeability of that blood-brain barrier. So we literally can say that, high histamine or histaminergic overload can cause leaky brain. And then the astrocytes and microglial cells both express histamine receptors as well. The astrocytes seem to express like all the histamine receptors. It wasn't really like any one specific one. Whereas the microglial cells, it's the histamine 4 receptor. And of course, these are just like technical details that don't really matter a whole lot for what we do, but they're cool to know. But so the histamine, it causes astrocytosis and the activation of the astrocytes. It drives the activation of the microglial cells and really just facilitates this leaky brain phenomena and the neuroinflammatory kind of excitotoxic cascade. And, something I've been thinking about a lot lately is the more that we learn about autoimmunity, the more it seems that, almost every disease and condition has an autoimmune component to it, right? This autoimmune kind of phenomena, they as in conventional science or healthcare always says, we don't really understand the etiology of autoimmunity. And yeah, I mean, we don't have it all figured out, but Alzheimer's is considered an autoimmune condition, and Parkinson's, and obviously multiple sclerosis and whatnot. So I was thinking about it with all my microglial activation stuff. I'm like, all right, if these microglial cells are the innate immune cells of the central nervous system, and when they get triggered and they're causing, kind of this bystander sort of collateral damage to the neurons and causing the two major pathways that get dysregulated with this neuroinflammatory cascade that then causes, these neurotransmitter imbalances like the serotonin, deficits, or, these monoamine deficits like dopamine or whatever it is. There's that kynurenine pathway that I always love talking about. And then the bioterin, or some people say biopterin pathway, which is, that BH4 being a huge cofactor for the production of serotonin, dopamine, norepinephrine, so on and so forth, and nitric oxide as well. I know McKay gets excited about nitric oxide. And, with that bioterin and kynurenine pathway, both of them get triggered and induced, potentiated by interferon gamma, which I think is really interesting that, this one kind of pro-inflammatory cytokine and interferon gamma triggers both of these pathways that have very, very similar functions. And both of them really cause this dysregulation of our neurotransmitters. And so anyways, something I've been pondering is, I think within the coming years, we're going to see more and more of an argument being made about even major depressive disorder and depression being an autoimmune condition. And I've been digging into that a little bit, and I haven't really found a whole lot of literature that really blatantly says that. But I think with microglial research, more and more we are going to see that, yeah, actually, maybe not all depression, right? Because of course, with depression or whatever, is it more psychological in origin? Like, are they just miserable people that have whatever more psychological issues, or is it more physiological in origin? So, I think we could maybe make the argument that at least a subset of depressed clients and patients, it is more of an autoimmune phenomena where, these innate immune cells that are the microglia are kind of, accidentally attacking, destroying neurons. And that neuroinflammatory cascade is so self-perpetuating. That's where a lot of the neurodegeneration kind of comes in. So I think we'll see more and more about that. But I thought this was a really great illustration. And this is why, I love whole blood histamine as a biomarker, as a blood test. I think it's so relevant for any of our chronic complex illness and, chronic toxic burden and mental health. Because decreasing that histaminergic load, I think, can be so therapeutic for, whether it's anxiety or psychosis or just kind of the whole shebang.